Hello, I will show you how to create a simple project in RobotStudio and how to operate a robot. You can simulate a real robot here. Here you can two options. You can create an empty station or create an project with a robot. You can choose here the type of the robot. But I prefer empty station. Now you can choose a robot. Our robot in laboratory is IRB 120, so we will choose this one. Mm, and we need to add a controller, virtual controller from layout. There are many options, but we will not change anything. So instead of choosing next, we simply choose finish. If the controller is OK, you obtain here a green light. Now we will hide the robot and create a tool. It will be combination of cylinder and cone. Each direction has its own color, and here also you can see the global reference frame, and has also three different colors. So we are going to change the Z coordinate of the cone. The cylinder has 50 millimeters height, so we need to shift the cone 50 millimeters. And we can rotate it also. Mm, we need to rotate it in local reference frame. this. Okay, so now shift with mouse can help us select more elements, and we will create a group. That's it. Mhm. And now we can transform this to the tool. So in modeling, create tool. Uh, and name is okay. Instead of use dummy, we will create a tool of our existing object. So we choose a group, and yeah, the tool needs center of gravity. It can be 50, for example. Mass is more or less okay, and that will be 110. Maybe this will be row this. Okay, it will be not precise, but we need to create some dimensions, so it can be like this, and done. So you can see that the tool center point is not at the end of the cone. We can scroll, can increase and decrease. When we keep pressed Control, we can move it, and if we keep pressed Control and Shift, we can rotate it. Okay, so you can see where is the tool center point. Yeah. It's not precise. Okay. And now we can attach the tool to the robot. Attach to. We choose the robot. We choose hold the robot. Yeah. Here are parts of the robot, so we need to choose the whole robot, and we want to update the position. Okay, so now we can make robot visible, and we can see that the tool is attached correctly. Diameter is okay. Oh, nice. Okay. So now we are ready to open the teach pendant or flex pendant. There are different names. If you want to move this window, you can click here, for example. So on the flex pendant we have joystick, some buttons with important functions, and this is touch screen. So we can choose menu start. I call this like in Windows, menu start, and jogging. So here you are operating with mouse, but if you will have real flex pendant, you will operate with your fingers. And we can choose here the mode of the motion, the type of the motion. And so now we are in internal space. We can control axis 1, 2, and 3. Tool is now tool 0. So the robot is thinking that it hasn't got any tools. And it's in automatic mode, so we must switch it to the manual mode. It's here, operating mode in menu controller, and we switch to manual. Now we come back to the teach pendant, and now let's try to change a tool. The tool we have added is not visible here. I'm surprised. So let's try to solve the problem. We come back to home menu, layout. We can see that there is a robot, there is my new tool. The tool is attached to the robot. If we look here, we can see that in the system there should be tool 0 and my new tool row. Because the tool is represented by the coordinate system of the tool, the TCP. So maybe the solution is the synchronization with the rapid. Because if we switch to the rapid and see here, model 1, that is all what is in rapid, so it's empty. Let's try to synchronize the station with rapid. Paths and targets. Yes, the tool must be also synchronized. Okay. Now, if we look here, the tool is present now. And if we come back to the teach pendant, we can see that we have now some windows opened. Jogging. The mode is switched. Uh-huh. Yes, the tool is present. So we can choose this one. Okay. And we can also create a new tool. Yes, because the TCP is not written precisely. So we can go to program data, tool data, and we can create a new tool here. New tool 1, scope, can be global, persistent. We are not going to change the coordinates of the tool. Yeah, it's okay. And it would be good also to create a new module. So each of group which is working with a given robot should have its own module. So let's go to program editor. We can see the list of modules here, and we can create our module. Um, yes, this is typical question. Yes, I will name it like this. Uh-huh. Okay, and now we can come back to the list of tools, and we can modify the place of this variable. So edit, change declaration, and now I can choose my module. So let's do some order in the system of the robot. As I said, each of you should have its own module, and there will be all your programs. Okay, so we can see that the tool 1 is inside module Robert. Nice. So now we are ready to calibrate the tool. We have two windows, the same windows, so we can close one of them. Okay. So we have program editor, we have program data, we have jogging, and production window. We don't need it, in fact. It has been opened automatically because there was automatic mode, probably. I'm not sure. The mode is switched once again to auto. I don't know why. In real robot, it don't work, don't switch itself. It will be always in manual mode. Okay, so let's start the calibration of the tool. Tool 1, edit, define. Here we can choose number of points. 3 points is enough, and we will calibrate the TCP. Okay, we chose the first point, and now we need to move the robot to the reference points. So we need to create a reference point. So you need to add another coin which will be on the floor, and this will be the reference point. Okay, we've got the reference point, which will be the top of the coin. The system don't know where is the reference point. Okay, so it must to find the dimensions of the tool and also find the position of the reference point. So now we will use the teach pendant and we will move the robot. We can switch to manual mode here in menu controller, and also on teach pendant, if you click here this button, you will see the buttons on the control cabinet, and here also you can switch between automatic and manual mode. And now the manual mode is chosen. You can see that here is an icon of hand. Okay, if you want to keep pressed the deadman switch, you need to simulate it here. Yeah, enable must be chosen. And now the robot will move if you will use the joystick. So let's go to home, switch to teach pendant, and the robot is moving. We can go to jogging. And here we can see the directions of the joystick. Left, right will be the first drive, up, down, second drive, and if you rotate it, it will be third drive. First, second, third. And next three drives are here in the wrist. The joystick has 3 degrees of freedom. So in KUKA robot, the joystick had 6 degrees of freedom. So here you need to switch between 1, 2, 3 and 3 and 4, 5, 6 drive. And the switch is here. You can choose it. Yes. And also here. This button that also can switch. And you have third option. If you click this button, you can see additional menu. So the icon of robot, show details, and here you can choose the internal space and external space, the Cartesian space. If you choose Cartesian coordinate system, you can choose which one it should be. The global, this is work object. No, sorry, this is the reference frame of the tool. This is work object. That's it. And if you have this icon, you can move the tool along one of the chosen axes. And if you choose this button, you will be able to rotate the tool around one of the axes. So here you are in Cartesian space and you can choose which one it should be. And here you are in internal space, which is only one. So you cannot choose anything here. Yeah. Okay, this is the sensitivity of the joystick. In practice, 100 is too much. I suggest you to use 20%. It's enough. Mm, In real robot, there should be something else, but we cannot see here. Here is a step-by-step motion, so you can choose continuous work or you can choose the size of the step. Here is a loop. So if you run your program, you can run it once, or you can run it in continuous mode. If it will end, it will start from the beginning. Yeah, there will be a loop. This is if you will execute your program step by step, here you can choose the size of the step. And here are this is the speed of execution of the program execution. Yeah. If you start first time your program, you should choose 10%. Mm, Here you can choose tasks to do. Sometimes there in the system will be more tasks, but it in such a case it's quite complicated. So usually there will be only single task. So uh, Mm, the task is the biggest thing. In task you can have modules, and in modules you can have routines. Mm, So once again, here you choose the speed of program execution, and here you choose the sensitivity of the joystick, the speed of the joystick. Here you can switch on and off the step-by-step mode. You can see that this icon also changes. Yeah? Okay. So let's come back to our tool calibration. We are now in internal space. Deadband switch is pressed. So let's approach. Now I'm rotating the joystick. So we need to see it from different directions. Yeah. Mm, we will switch to Cartesian space. Okay, and now we can choose the coordinate system, the global one maybe. So there is a word coordinate system. If there are more robots in the robotized station, this is a common reference frame for whole the station. And this is the reference frame of a given robot. Yeah, and then tool reference frame and work object reference frame. Reference work object is a reference frame which is connected to a table on which the robot is operating. Mm, Oops. So here, if we click here, we can see here you can see messages from the system. And here you can observe the speed of program execution and motor zone because the deadman switch is switched on. We are in manual mode. Mhm. Mm. So why I need to see it from different directions. And now you can observe the final alignment of the tool and the reference point. Looks quite good. And we can observe all the robot, the shape of the whole robot, because we must do it 3 times. Each time the wrist must be configured in different way. So we've got this first approach. We go to the calibration procedure and we choose modify position. So we have first point. Now it's good idea to switch to the rotation. So you can use this button. Now we are in translation mode. If we click it once again, we are in rotation mode. Okay, and let's try to rotate. We can go to jogging and we will see the directions. So up and down will rotate around x-axis. So the axis of rotation will be parallel to this line and it will go, of course, through the tool center point. So maybe through this frame, or maybe it will go through the end of the robot, through this point. Let's see. Up and down. Uh-huh. The tool is not calibrated yet, so for sure it will not rotate around this point. Uh, it seems that it rotates around this point, yeah, because now the tool on the robot in this time is my new tool row. Yeah. So around the rotation axis go through the TCP of this tool. I can see the robot. I think we can rotate it more. Yes. And let's see it from different directions. Yeah, it could be better for sure. So let's switch to move and let's improve it. This is the final result of this approach. Can be. I hope in real you will do it better. So we can confirm the second point. And third one. And this is the result of third approach. Quite nice. And you can see how the robot is rotated. And we choose modify position and OK. Something's wrong. I don't know what. In the case of virtual robot, you can also move it in this graphical window. You simply choose jog TCP or jog joint. There are different possibilities, and you can move the tool using this. But in real world, you have only the teach pendant. Yeah, so I was trying to use this joystick, and it's not so easy here if we have only two-dimensional image. I have improved the second point, and let's see how it will work. So I can improve the second point simply by choosing modify position. And you can see that it's quite precise. I hope it's better in the previous. Yeah, it looked good. So let's try, maybe this time it will work. Something's wrong, I don't know what. I'm calibrating a new tool. I don't know. You should remember that we have here two spaces. The space of rapid code and the space of the graphical window. And if we do something here, we will observe it here in layout or in paths and targets, and it will not be not present in rapid. So you need to synchronize the station to rapid. Now we have more code in rapid because I have created a new tool, a new module, module Robert, and we need to synchronize it with the station. Synchronize to station, and I think we can synchronize everything. Okay. So now the new tool, which is not calibrated, is present here. And we can try to correct its position here in graphical window in station. So let's try. Set position. We can choose this is new thing. You can here expand the buttons or collapse the buttons. And we should choose snap to end. Snap to end. And now I will switch off this. Switch off this. We need only this. And now we must to place the TCP at the end of the cone position. So the cursor must be here. And now if I click it, the coordinates are written here, the coordinates of the end of the cone. And I will apply it. Okay. And close. And also I can correct the orientation. So I right click here and rotate. And here we can choose the axis of rotation. I would like to rotate it around X. So X, and let's try 10 degrees, maybe 5. Apply. Uh-oh. Because it's rotating around in the global coordinate frame. So I must to press Ctrl Z, and I need to choose local. Yes. I must do this manual rotation and movement, but I'm not sure if it works with respect to coordinate system. So 5 degrees around X, apply. Maybe minus, it should be minus. Let's see from another directions. So it should be rotated around Y also, but without minus this time. Oh. So this is the final result. I think it's not bad. So we can close it, and we've got a proper tool now properly calibrated. But we needed to do it here in the station window, not by the use of flex pendant. So I'm surprised a bit. You can try, because I want you to uh, do some exercises at home with the flex pendant. So you should be ready to work with real robot in the laboratory, and you will always you will only have this flex pendant for the calibration and operation of the robot. So now we have a mix of operation with the flex pendant, and sometimes I need a support from this virtual image. Okay, so let's switch to this tool, set as active, that's it. And now we will create a program, but now we must to synchronize this station with the rapid, and we will come back to the flex pendant. So synchronization to rapid this time. Okay. And let's create a program now. Uh, this window is not necessary. Program data. Here is the calibration still opened. I can cancel it. Yes, I'm sure. Okay. And now, so if we go to Rapid and look at the tool number 1 in module Robert, now the dimensions of the tool will be the result obtained here, yeah, because of the synchronization. Now we are going to create a program. So this is a list of modules. There is a my module also, a show module. So there is only tool data now. There is a beginning and end of the module, and I will add a routine here. So I have switched to routines, file. Oh. What's the problem? Probably this is the reason. The system itself switches to automatic mode, and probably we could not do the calibration because of this also. So once again I will switch to manual mode. Okay, and let's try. Yes, we've got it. New routine. Route 1, it will be procedure. We have three choices here. Procedure without any arguments, and it will not return any values. Function, which you can take some arguments and return some values. And trap is a kind of interrupt. We'll do it later. So procedure in my module, it's okay. Um, Okay, we will come back to the program for a while, but now there is another thing related to the tool. So now we are in jogging window. I will choose my tool, which has been already calibrated. Okay, and mm, we cannot use this tool because it has not all proper parameters. So after calibration, we need also change some values manually. So we come back to program data, tool, edit, define the calibration using 3 points was here. And now we need to go here, change value, and we need to, we can observe this here. This is for scrolling, yes. And here we have XYZ of the tool. So we can see that Y is almost 0. These are the dimensions measured with relation to center of this ring. Yeah. So Y is almost 0 in this case. And let's scroll down. The mask must be changed. This is an assumption of the system, and the minus is for the user. He needs to come here and change it. So simply 1. It can be 1 kilo. And another thing which needs to be set is the center of gravity. This is called the vector, and here are 3 coordinates, and it cannot be 0. So we will change Z to, it's in millimeters, 40 millimeters, for example. Okay, so this was 2 things which need to be changed here: mass and center of gravity. Okay, and now we come back to jogging, and we are in the tool choosing mode. So once again, tool 1, and we've got it. Now the tool 1 is attached to the robot, and it will operate with this tool. If we want to check if it's correct, we can move the tool close to the reference point. I will switch this snap, and I will jog it using this. It's quite simple, yeah? But you can do it with real robot. You can't do it with real robot. Yes, and I will switch it off. Go back to view, to flex pendant. Maybe I will move it here. And now flex pendant. And rotation. And now it should rotate around this point. So we are close to the reference point, and we can observe if it go away from this point or not. We need enable. This is okay. So this is practical method for testing the TCP. And after calibration, always you should do it. And that, mhm. So seems to be okay. I hope so. Now we can observe the reference frame, the two center point. Yeah, it's here. But in the real world we cannot see it. So the verification by the rotation of the tool is very useful. Okay, so now we can come back to the program. Program. Where are you? This is program editor. This is our routine. We can choose. Uh, so once again, uh, show routine modules. So you can see the modules, and if I click this module, Robert, we can see the the, proceed, the the beginning of the module, and inside here is before the routine there is the declaration of the tool, and here is the routine. So now we are ready to create some instructions. So we choose this line, and instead of this there will be a first instruction. So now in editor we have three possibilities: add instruction, and here are the common instructions, and you can choose now you are, yeah, so there is a lot of different sets of instructions. Usually we will use common. And this was add instruction, edit. Here you can cut, copy, paste, and so on. And here is the bug for execution of the program. So let's add the instruction. We do it in the way teaching by doing. So uh, the robot should draw something. Yes. So I will layout, choose this part, and I will remove it. The robot will draw something on the floor or on the table. And I can move the robot using the controller. I must to switch to movement. Yeah. And I am, if I look in jogging, I'm in a world coordinate system. It's okay. So Z. Left will be up and right will be down. Yeah, something like this. I don't know if we are on the floor or not. In two-dimensional image, it's not so easy. Um, Now maybe. Okay, go to the program editor and it will be move L. Yeah, the instruction is added, and we can change something here. But maybe, mm, yeah, this is the middle of the program. We should start from the home position. So I will not correct it yet. I will move the robot up. This will be home position. Yeah, add instruction, and it will be move J above. This should be at the beginning, and then there should be point which don't touch the table. It should be a couple centimeters above it, and this will be also move J. After this, below, yes, move L. Here we will be on the table, and now uh, I will teach the robot next point. Now I am in internal space, and I switch to Cartesian space and go down on the table. It's not so easy. Yeah, it's a bit too high. Ah, something like this. And it will be next move L. Okay. And now move up. And this will be also move L. And go to home position will be move J. I can copy this one, edit, copy, paste. Simply and easy way. Okay, so this is a short program which will draw one line on the table. So here is home position. This is approaching point which is above the table. And here moving to this point can be quite fast, and we don't need to control the shape of the trajectory. So this is move J also. And this is a short movement which the tool will touch the table, and from this point to this point the robot will do single line, short line. Here moves up from this point to executing this line, moves up. This is linear motion, because here we need to control the trajectory. This must be linear motion when we uh, remove the tool from the object. Yeah, and if the tool is in a safe distance from the object, then the robot can switch to faster movement and we don't need to control the trajectory. And here goes home to home position. Okay, and we can run the program. We need to set the program pointer. The program must need where to start. So we can go to debug, program pointer to routine. My routine is route 1. Okay, program pointer is here. Deadman switch is pressed, and now I have the speed of 10%. This is 10% of the safe speed. The safe speed is 25 centimeters per second. If we set 100% here, the robot will work 25 centimeters per second. Okay, so I should first time I should run this step by step. So I will use this button. Ah, it works. So this is home position. This is above the table. Yes. Touching the table. One line. Move up and come back. Nice program. Very nice. And now we can manage the speeds and the targets. We can double click on single of chosen instruction, and the point has not a name. So here it's under the star, yeah, the point. So normally the instruction is quite long. We can look at it here. Rapid. Yes, you can see that move J has a an argument which is a target. It's all those data. Then is the speed, the Z zone, and the tool. Tool is correct. The tool here is the same like here in jogging. So before you start creation of the program, you should have properly calibrated tool, and the tool should be switched here in jogging. Yeah, then you can start programming, and in this case you will have proper tool in all instructions. Okay, so instead of those data, here in Flex Pendant, you can see a star. So if you open it, you can see the coordinates of the point. And, well, you can name the point, but if you click New, the system will not take the coordinates which are here, but will take the coordinates of current position of the tool. So it will remember this position. So how to create a new target based on the data which are already in the program? I have only one solution. Maybe there is another, but I don't know. Cancel. That switch is pressed. So you can see here a program pointer, and this icon shows us where is the robot currently. Well, it should be in fact at home position. Yeah, but home position is here and here, so it's correct. Okay, now the robot is here. And if I double click here, now I can name this point, because these coordinates are the same like the position of the tool. So new, 3 dots, it will be home. Home. Okay. Global scope, constant. We are not going, we don't need to treat this target as a variable, so it will be constant. In module Robert, wszystko jest everything is okay. Nice. And we have on the list of targets, we have home. Okay. Okay, and now I need to go to next point. Yes. Open next one and name the next one. New. This will be up 1. Okay. And okay. And okay. And move to next point. Hello. Uh-oh. Here we can also come back. Something. But in fact, we should not use this button too often, because we run the program from the end to the beginning. Did you try anytime to run your C code, for example, from the end to the beginning? We cannot predict everything, so sometimes we can be surprised. Yeah. Because I didn't name proper point. Ha! So I've lost this point. Yeah. So instead of this point here, it should be in this line. Now in this line we have this point which is too high. So I have done mistake. So you can continue, you can name all the targets, and your first classes task is to calibrate the tool and also to draw something. The tool will be a pen. Yeah, we will connect the pen to the gripper of the robot, and you will calibrate it and draw something. So I think this is not the end. There is another thing which is quite important that should be done at the first classes. I have added here a box which represents a piece of paper. In reality, the piece of paper will be put on a rigid plate. So the height of it is of 30 millimeters. And we add a coordinate system uh, connected to this plate. And all the targets should have uh, coordinates expressed in the work object, yeah, in the local reference frame. So we have a kind of chain of reference frames. There is there is a global reference frame, the base reference frame, which is under the robot. Then will be the work object, and then will be the targets. I will choose this and move it, something like this, for example, and we can start the calibration. So I will go to the flex pendant. Um, it's in program data. Here we have list of tools. Here you can read the information and view data types, work object data, show, and there is only work object 0, which is aligned with the base of the robot, and we cannot change it. So we need to create another one. It can be like this. Scope can be global, and we save it in module Robert. It's okay. And now the calibration. Oops. I will shift it a bit, maybe like this, and expandant, edit. It's similar to the tool menu. We choose define, and the work object has two reference frames. In fact, we will calibrate this one. So the object method is inside, the object reference frame is inside user reference frame. So if we calibrate only one, these two reference frames will be aligned. We need to point 3 points. We need to have properly calibrated tool, because the tool will be a pointer. Yeah? The robot will measure the points in the space using the tool. So the tool must be calibrated. We need to point 2 times the x-axis. The direction of the x-axis will be from x1 to x2. We don't need to point exactly the origin of the reference frame. It's enough to show the system where is the straight line aligned with the x-axis. Yeah? So these 2 points will define the line. And then we need to show 1 point on the y-axis. And the system alone will find the line perpendicular to the straight line of x and going through the y point. Yeah, so it will find the origin itself. It will be the crossing of these two lines. So let's do it. As you know, we can move the tool using the teach pendant, but I want to do it faster, so I will move the tool using this graphical interface. I need to switch off this and choose this and choose this. Yeah. Mm, oops. Yeah, more or less. Let's go to teach pendant and modify position. Then not bad, not bad. Modify position. So here will be X and now Y. Are we on the edge? Not yet. Oops. Maybe now. Even better. Uh-huh. It's okay. Flex pendant, where are you? Okay. So that's all. We are in manual mode. So I hope it will work. Yeah, we've got it. So this is the position of the work object. This is orientation written in quaternion. So this is the result of the calibration. Okay, and now we need to verify if it is correct. How to do it? We go to jogging and choose coordinate system, work object. And now we need to choose which work object. Yeah, this is very important. This is our work object. And now it's linear. Okay, so here in this window we can observe the coordinates of the tool expressed in this work object. So we can see that only y coordinate is different than 0 because now we are on y-axis. Yeah. So let's go to the origin. Something like this. Now we should be close to 0. Yeah, we are close to 0. So it's okay, and we can move the tool in the in this coordinate system of this work object. So z, x is here, y is here, so the z will be up. So if I rotate it left, the z will be increased. Yeah, the tool is moving up, and we can observe that z is even bigger, but y changes. No, y is constant. So we are moving vertically. Yeah, we can see that it's not precisely put, but in a real world it will be easier to verify it. So if you will create a program and you will draw something, first of all you need to create the work object and then create following targets which should be inside this work object. Yeah? If you will do everything correctly and and change the position of this plate and change the position of the work object, you obtain the same drawing in the same place of the paper, even if it will be in another place on the table. Okay, thank you. I wish you all the best. Please be prepared to Monday.